Okay, in this lab, we're going to do this mini case on a company called BlueStar, wholesale supplier of office products. We essentially have data on the transportation, and we're going to help them reduce their transportation costs. So you can read the background of the company. It's an office company, and they ship office products to retailers, distributors, small businesses, big accounts like IBM, Toyota. You can think of paper clips, printer paper, maybe printer toner, notebooks, pencils, markers for whiteboards, stuff like that, right? Office supplies, envelopes, things like that, right? And so they're having a problem. The transportation costs have gone up a lot, about 30% of their product. And so, the VP Pat has hired you, and Pat says, "Let me make this simple. Tell me what I need to do to reduce transportation expense. Um, Tell me what I need to know. Tell me what I need to do, and tell me what we can improve. I need to reduce costs and improve service. Give me tangible data driven recommendations that are actionable." So basically, Pat is telling you, do my job for me, fix this transportation cost issue. We are not making a lot of money because transportation expenses a large part of our costs. So they give us some data and they say these are some questions. We have to do some basic statistics and maybe then look at some shipment consolidation to help them save costs. So this is what the data looks like. It's an Excel file. And they have these fields. SCAC is a unique identifying code for each transportation company. Then you have shipment type. Actually, let me just open the Excel file, and it will be easier to illustrate what data we have. So this is the data we have. And you can see there's a code for the company we use. Shipment type, this can be air, truckload, less than truckload, intermodal, which is rail plus truck. Then the name of the company. So this is the code, this is the name. So each code is associated with the name. So EUSA is Eagle USA. The month in which the shipment happens, so month 5 is May. The date of the shipment, the origin city, origin warehouse, origin zip codes, like the address where the shipment originated, one of their warehouses, obviously. Going to South Bend, Indiana, this is the zip code, that's the destination address. They're not going to give you the street address of their customers, but close enough. The weight of the shipment in pounds, so it's 3,302 pounds. The distance you had to travel between origin and destination zip codes is 263 miles. The company sent us an invoice for $3,552.01. That's the pre-audit amount. That's the invoice you get from the transportation company. Then your people look it over to make sure that things like fuel surcharge are computed correctly, and whatever transportation rate they discuss with you, they've applied it correctly. They make any necessary adjustment, and then they realize, oh no, they're trying to overcharge us a little bit, and the actual bill should be $3,477.01. So they adjust that and pay out $3,477.01. So this column, freight paid dollars, is how much we're actually paying. Obviously, if they keep trying to overcharge us, that's not a good company. But that we can look at that later. But right now we have this transportation expense is very high in general overall, and we need to analyze this data and see what's going on. Okay. So let's get started. So this is all, we're going to use this, it's called a Jupyter notebook or a Python notebook. We're going to use this in Google Colab. So you go to this link, okay, and you can upload this IPYNB file, the starter file that is provided to you on Canvas, to your Google Drive. Usually you want to make a folder on your Google Drive. If you go to your Google Drive, okay, there will be a folder called Colab Notebooks. You can just open an empty, you can go to colab.research.google.com, start with an empty notebook, and once you do file save, it will save it in the Colab Notebooks folder. So if the folder does not exist for you, you can just open an empty notebook, save it to create that folder, and then you can upload this starter file from Canvas into that Google Drive folder. The reason you wanted to create the folder is because it looks for files by default in that folder, so it's just easier if your file is saved in the Colab Notebooks folder on your Google Drive. So once you have the file there, you can double click to open it in this software, and then you can read the text description, what you have to do, and then you can insert code blocks anywhere, like a code block here, to write your code to do the work. Okay. Now the couple of packages we're actually going to use in this lab are pandas and matplotlib, and these packages are already installed in this software, so we don't have to do anything. But if they were not installed, you would run a command like this, exclamation mark pip install name of the package you want to install, and if you run this, it'll tell you that it's already satisfied, it's already installed, right? So you don't need it. Okay. So in future, if you have to use a package that's not installed by default in Colab, Google Colab, so you can just do this, exclamation mark pip install and name of the package into a code block, run it, and that'll install the package. So we're going to start by reading in the Excel file. So I'm going to do this whole lab, and you can kind of just follow along the video and do the lab yourself, and then you're going to send me the screenshots of the result that I'll indicate in this video. There'll be 2 plots and then a couple of tables. You'll put screenshots in a Word document and upload that to show evidence that you finished the lab. So first things first, we're gonna read in the Excel file which is given on Canvas. That's called BlueStar data v2.xlsx. That's our Excel file with the data, and I recommend you copy it into your Colab Notebooks folder on your Google Drive, the Excel file, so you can access it through here. You can also drag the file like this, drag the Excel file into this temporary data, and it gives you a warning. Any file you drag into this files area is temporary, it'll get deleted. But you can click this button to mount your Google Drive, and then you can access any Excel file on your Google Drive. So I recommend not putting your file here, because when this virtual machine that is running our code shuts down and restarts, because if you were away for a while or you closed and reopened your notebook, then this file will no longer be there. It's like temporary storage. So just go to your Google Drive and go to the Colab Notebooks folder. If it's not there, just open an empty notebook, hit File Save. And then in this Colab Notebooks folder, you're going to copy the Excel file from Canvas and this starter IPYNB, which is interactive Python notebook file, into that folder, and then you can double click this file to open it in Google Colab. Okay, so we're gonna write actually the code to open up the Excel file. Okay, so we're gonna say we're gonna ask AI to help us. I guess say, okay, write some Python code to open BlueStar data v2.xlsx, and maybe I'll put it in quotation marks so it doesn't think BlueStar is a word, it's a name, to open this Excel file that is in the Colab Notebooks folder on my Google Drive using okay, open this and load the data into a pandas data frame so I can work on it. Okay, so it wrote some Python code. It's doing mounting the Google Drive, it's doing a file path, and it's loading up the file, and it's trying to do all this try except stuff to give us a nice error message. But I'm okay with the default Python messages. I don't want to put in these try catch blocks. I'm not making an application for the end user. I'm just writing some script to help me analyze the data. So I'm going to tell it to do not use try except for error handling. Okay, so it removed that, and I also am going to take out the I'll just show you. So let's just run this code and see if it loads the file. So connect to Google Drive, it will ask you permission. We'll say connect. Yes, you can connect to my Google Drive. Okay. Okay, let's see what it does after getting permissions. So it's just the first time you run the first cell, it takes a little bit of a time. I think it's loading Python. So here it is. It showed us some data. So let me actually delete this file just so that you're sure that it's not reading this file. Not download, I want to delete it. It's reading the file from a Google Drive. Okay, so I'm going to do a couple of things. You can mount Google Drive using this button, so I don't know if I really need this code. What I'm going to do is I'm going to remove this, and I'm going to take out the print, because you can just do df.head, which is your data frame, and it should show you the first 5 rows. Head means the header, or like the first 5 rows. See if it's already mounted. It doesn't like running this code again, tries to mount it again. This takes a while, so I can just remove this code. If you want to mount Google Drive, you can just click this button to mount your Google Drive, so you don't need this code really. And what I can also do is I can move this code into, okay, this is fine. And so here you can see your Excel file has been loaded, showing you the first 5 rows. Okay. And so it generated good code. This is the code I used. I called it shipments because that's shipment data, and I also specified sheet name 0 to load the first worksheet, because if there are multiple worksheets, it may load something else. So what I'm going to do is I'm going to update this with a little bit of improvements that I did. So I'm going to say sheet name equals 0, and I'm going to call this data frame shipments, because this is shipments data. DF is just a very generic name. I want the name to mean what it's doing. Okay, and I can delete my old code. So let's keep this code. Okay, and now it should work and give us shipments. Now, next we're going to do some couple of steps that we usually do when we open Excel data in Pandas. So you'll notice that the column names have a space between them, and some column names have a $sign. For certain types of accessing the data in a Pandas data frame, it's easier if there are no spaces and no special characters in the column names. So I'm going to rename all these columns. I'm going to take out the $sign, and I'm going to delete all the spaces in the column names. So the way you do that is you take the data frame shipments, you do dot columns, right? And you can say equal and just assign it the new names. You have to pass it a list, which is with these brackets, right? So, that will rewrite the names of the columns in this columns variable with the names you provide. So my first column is SCAC, which is fine. Then I do shipment type. You have to use quotation marks without a space, carrier name, ship month. So instead of ship mo, I made it ship month, which is easier to understand what it is. Ship date, origin city, origin state, origin zip, destination city, state zip, weight, miles, pre-audit amount. So I know it's like a dollar amount, and freight paid amount. So I'm going to run this code, and you'll see it renamed the column names to be without spaces and special characters. Okay. Now, what we can do is you can look at, let's insert a code. You can look at your how it's storing the data by typing the name of your data frame and typing D types. Okay, and that's going to show you the data types of your data. So it's storing SCAC as an object. If you look at this field, it's just some text. It's just like letters and maybe some numbers. Shipment type is also letters. It says text. Carrier name is text. Origin city is text, origin state is text. Origin zip looks like a number, but it's actually text because they're also shipping to Canada, and Canada has postal codes with letters in them. So some of the rows will have letters, and then some of the zip codes will be 9 digits, so 5-digit major zip code, and then the additional 4 digits. And so it's just easier to make it into text to be able to handle Canada. You know, especially if a company is doing international shipments, many countries have like text-based postal codes. So you don't want to make the zip column a number in your analysis unless you really have a good reason to. Okay. And so all of these databases are object. I'm going to change them to string because things work faster when they're working with the actual type, the actual string for text data. Object is very generic. Object can store many different things. And so because we do have text data, we can tell it, hey, we don't use objects which are slower, just store everything as string except ship date, which is date time, and except the numbers, obviously. Weight is a number, so int stands for integer. Miles is a number. Pre-ordered amount is a floating point number. It has fractional parts because you can see 0.01, 0.36. And then freight paid amount is also floating point. So they're all fine except the object ones. All the object ones need to be converted to string. So you can try using AI for that. You can say, for my shipments data frame, convert all columns of type object into type string. Okay, and it will give you this code, which is a little bit different than the code I have, but I'm just going to show you. I think this is going to work as well. Yep, it did work. It changed all the objects to string. But in any case, you could do that, or you could just write the code that I'm using, which is straightforward as well. I'm saying for column col, just a variable name. I'm saying assign each column name to col one at a time in shipments.columns. Remember, our data frame has a .columns property which lists all the columns name, which is the property we changed right here. Right, so you can write to this property using an assignment, but you can also read this property. So I'm saying for every column in columns, put that value in col. Then I'm going to say if shipments square bracket col, that's the column, dot d type, its data type is object, then replace that column with a new shipments dot column, which is converted to as type comes into type string. And this loop runs over all the columns and converts that to string. Then I also don't like that I don't have a freight rate. Freight rates are often calculated as how many dollars you spend to move 1 pound or 1 kilogram or 1 ton, 1 mile distance. So weight and distance, you divide by weight and distance, right? And so I'm not going to use tons. I'm going to use CWT, which is called cent weight, which is 100 pounds. Why? Because a lot of our cost, as you'll find out shortly, is in LTL shipments. And with LTL shipments, the LTL shipment rates are often listed as dollars per centweight mile. Like, we charge $3 per centweight mile. So if you want to ship 100 pounds, 3 miles, we're going to charge, $3 for that. Right? 100 pounds, 1 mile, sorry. If you want to ship 100 pounds, 1 mile, our rate is $3. We're going to charge $3 for that. Okay, so I'm going to make a new column in my data frame by saying shipments, the name of my data frame, these square brackets, and then I type the name of the new column I want in my data frame. It's just like creating a new column in Excel. And this new column is going to have the old column values of freight amount paid divided by the weight in cent weight, or weight was in pounds, I divide by 100 to get cent weight, times the miles. So I divide by how many cent weight were moved how many miles to get the dollar per cent weight per mile. Okay, and then you can do shipments.head to see the new column. Okay, and you can see here is my rate. So for this shipment, they charged me $0.4 per centweight mile. This shipment seems very cheap, and this shipment is 0.15. You know, there's some concern I have about the actual amounts in this data, but this data came from CSCMP, and their claim was it's close to real data or something. But anyway, some of the numbers don't may not make exact sense. Like why this is too cheap for a shipment. Like how come you moved 31,000 pounds 450 miles and you only had to pay like 747. And also an air shipment, like that seems awfully cheap. I think this is mislabeled. This seems like a truckload shipment type of rate, or even this is too low a rate for air shipment. But anyway, we have to work with the data we have. In real life, you would obviously want to verify if the data is correct, but we can't here, so we're going to go on and work with the data we have. Yeah. So we fixed the columns and generated the freight rate column. Now we have some basic analysis, such as finding how much do they spend annually on their shipments. What's the annual transportation expense? Okay. So what is the annual transportation? Now you could sum up the freight amount paid column. That's the total amount they paid. But we don't know if we have data for a whole year. We could have data for multiple years. We could have data for part of a year, right? And so what the strategy we're going to use is this. Okay, this is our timeline. We have data starting on some day, and then we have data ending on some day, right? And then we have, the freight paid data for shipments at this time period. And we want the data, the cost, how much we are paying over 1 year. Now, the T2 minus T1 could be 5 years, 10 years, could be 3 months, 2 months. We don't know the time period of the data. So what I want to do is I want to calculate the number of days between T2 and T1. In other words, I want to calculate T2 minus T1. That'll tell me how many days of data I have. Okay. Then I'm going to sum the freight paid amount, how much I'm paying, right? And then I'm going to divide by the T2 minus T1. This will give me like a per day spend I have. And then I can multiply it by 360 days a year because you have like 5 national holidays or something. You can do 365, doesn't matter. Some people will do 360, some will do 350, depending on how many days their company is operational in a year. And then you can get the amount paid annualized, like on an annual basis, how much are you paying for transportation? Okay, so we can generate a code block and tell it, okay, for the shipments data frame, sum up the freight, let me just check the exact column name, FRT paid amount, and also calculate the difference in number of days between the minimum ship date, like the earliest date, and the maximum ship date. Okay, so the total freight cost, it did the shipments freight paid amount dot sum, will sum up this column, right? And it's printing the value out. Then it did the minimum and maximum dates. Then it calculated the date difference. Okay, so I'm just going to call it num days. And I'm going to take out this print here. I don't want to print that. Okay, and then I can calculate annual transportation cost is equal to total freight cost over num days. That will be per day. But then I have to multiply by the number of days in a year. Let's assume we are open for 360 days of the year. That's my annual transportation cost. I'm going to update the print statement to actually say annual transportation cost for BlueStar is, and then I'm going to print out this variable annual transportation cost dollars. Okay, let's run this code, and voila, we got, you know, this is kind of messy number with so many fractional parts, but if you look at it closely, it is about $167.8 million. We can add a colon and then do a point to say, okay, we need 2 decimal places for this floating point number, which means a number with fraction. Floating point just means number with fractions. And then it'll just print, you know, the cents to the dollar, so 30 cents. And this is a little bit nicer. Okay, so we've done the first part, calculate the annual freight cost for BlueStar. You can always go here and explain code to have the AI explain the code to you to see what's happening, right? And you can read that. It's kind of straightforward. What it's doing is summing up a column of the data frame, which is this how you do. You know, remember whenever you put square brackets in the name of the column, that's the part of the table you select. So it's like this part of our table, which is called data frame. We sum it up and save the sum in this variable. Then we calculate the minimum and maximum dates. We calculate the number of days, which is the, you know, what time period is covered by our data. And then we divide by those number of days and multiply by 360 days to annualize our cost. And then that's how much we're spending annually. If you look at num days, we don't have data for a year. We only have data for a few months. So we are, you know, extending that. You could print num days out. Okay, and see that you have data for about 4 months, right? And then you are extending it for the whole year to get your annual spend. Okay, so this annual expenditure, the code and this output, this is the first screenshot I need. So you go to sniping tool in Windows, okay, hit new, and just take a screenshot of this. Okay, and then you can open Word. Okay, and then you can copy and say my lab 1, put your name, first name, last name, and then you could put your screenshot 1 here, and then so on. You could put all your screenshots here and then submit this file at the end of the lab. Okay. Now we need summary statistics about how much are we paying for each mode, what is the weight that's being transported to each mode, and how many miles are being, you know, our shipments are moving for each mode. Okay. It's really easy with the group by and aggregate commands, but we're going to ask AI to do it first for us. So we're going to say, okay, group the shipments data by shipment type, okay, which is this variable right here about air, LTL, TL, because you want to look at, you know, the different modes, how we are using the different modes of shipments, and aggregate aggregate the data using sum, min, max, mean, standard deviation. Okay, and it gave us this code. It's doing group by with that, and it's aggregating all of these variables, and you can see the aggregated shipments. So let's see if this code works. Okay, so it did work. We have freight paid amount. For air, we're spending this much, intermodal, LTL, I don't know what SP stands for, truckload, and so on. But look at how terrible the data is printed, like 6.119 times 10 to the power 5. So there's a nice command called pd.options.display. Okay, so you can use this command, pd, which is for pandas, because you imported pandas as pd. Okay. and then you'll do .options.display.float format. This is format for floating point numbers which have a fractional part, and then we're going to say colon, that's just to specify the format, 0.2f, which is give me 2 decimal places. Okay, so don't give me like 600.508 blah blah blah. So let's run it again, and this is looking much nicer with this option set. If you don't understand this, don't worry about it. It's just we're setting some display options for the Python library we're using, and that's how you set it. pd.options.display.float format equals, and then you give it this input. Okay, and so that's how you could use the group by and then the aggregate function to make like a pivot table type of thing in Python, where you can get for each shipment type, how much money are you spending, how much weight are you moving with that shipment type. So you can see that our highest money is being spent on LTL, 33 million, and TL is 15 million. Intermodal is barely 2 million. So most of our transportation is LTL. LTL shipping is more expensive than TL. So if we could go towards more TL, that will save us some costs, right? That's one idea right there. And if you look at the miles, okay, in terms of average, right here. So our average shipment, LTL shipment, only travels about 500 miles. And our truckload also travels about 500 miles. Okay, look at air. Air is being shipped only an average distance of 332 miles. That is kind of insane. For up to 500 miles, truck is almost as fast as air, because you don't have to go to the airport and waste time loading up the aircraft, and because you can't load up a whole container into an aircraft, you have to make special pallets or something for the aircraft. And so there's a lot of work involved with air shipping, and so it's not worth it for small distances, right? And the minimum distance is 6. We send a shipment 6 miles away by air. That seems like some fat finger error. Maybe it was like 506 or 206, and they just typed in 6. But anyway, the average is very low for air, so we need to stop wasting money on air shipment for small distance shipments. Now we're going to make a bar chart of the costs for each mode type. Okay, so let's make a new code block, generate with AI, make a bar chart of freight paid amount by shipment type. Okay, it looks correct. Group by shipment type, freight paid amount sum. So that looks correct. Dot plot to plot it. And then we set the different options on the X label and Y label. Okay, so this is looking like a pretty horrible bar chart, because usually you want to have either going small to big or big to small. Don't want like this middle tower and then everything else on the other side. So we're going to say, and make sure it is sorted from highest to lowest. Okay, so I did sort values, and then it did plot.figure, plot.bar is plotting it right here. So let's see. Okay, so it's taken a while for some reason. So we're importing this library, this plotting library. Then we are first summarizing our data into sorted, this new data frame, which is going to be, oh, this is not doing the right thing. It's sorting the whole value. It has to first do group by and sum up the values. That's why it's taking so long. Let's stop this. This is incorrect code of total freight rate amount by shipment type and make sure the bars go from highest bar to lowest bar. Okay, this is still not correct. It's sorting the raw values here. So let's do this. Let's say make a bar chart of the sum of freight rate amount for each value of shipment type and make sure the highest bar comes first. Finally, we did group by. So this here, you know, sometimes AI generates code which is not correct. So I know that I have to do group by shipment type because I want to sum for each shipment type. So basically, I'm going to use this data. See here, we use group by. So you have to group by shipment type to be able to calculate the sum for each shipment type. So I need to do the group by first before I can do any bar chart plotting. So it does the grouping and summing for each shipment type. Then it sorts the values into descending order, highest value first, and then it makes the plot. So this should work, and this is looking nice. But what I want to do is maybe this blue color is kind of boring. So maybe I can specify the color here to the plot function. It takes a color argument, and maybe I'll do green. Okay, so this is a little bit better. Okay, so you can change the color here, or maybe I can do, let's see what other colors. No, this is terrible. Orange, or let's do pink. Okay, this is a little bit nicer, right? So you can change the color here. Okay, so you can see we're just getting done with the lab just using AI. If you have a sense as you work with Python, you'll have a sense of, okay, you know, here I need to do group by. I have to group the by shipments, all the observations before I can take the sum, because I want the sum for each shipment type. I don't want the sum over the whole data set. So once you know what the code looks like, you'll know if the AI made a mistake or not. So let's just copy this prompt. And by the way, you need to take a screenshot of this table and the code. So that's our second screenshot, like this. And we copy and paste into Word. And then the third screenshot, we are going to need is going to be this one, the plot. So and I get most of the code and most of the plot. Oh, that doesn't look very nice. Maybe I want to make the plot smaller. This is too big. So this is the size of the plot. So I can make it 8 and 5 maybe. Yeah, see, this is nice and small. And so now I can get this on the screen. Okay, and this is good. So that will be my next screenshot. Okay, now I need to make another plot, and you can kind of save these as images and put them in your PowerPoints and so forth, right? So I want to copy this prompt, and now I did this by the spend. Now I want to do it by the weight, and the bars are orange. Let's specify the color. Okay, so we don't need this import because we already have it imported. And so we have shipment type, group by, weight sum, very good. And color orange, very good. Okay, this is looking good. So then you can take another screenshot of this thing and put that in your lab document. Okay, now this code that is generating, if it doesn't make a lot of sense to you, you can always go here and do explain code. We're basically grouping our data by the shipment type. Then for each group, we take the weight column and calculate its sum. So we get the sum of the weight by each shipment, the TL, how much weight we shipped. So basically just this data right here. We're regenerating this table, but just, sometimes by freight paid amount, sometimes by weight. And we're then taking these sum values, these values by weight, and plotting them into a bar chart. And before we use the freight paid sum column, these values. So we are doing shipments that are grouped by shipment type, and then instead of aggregation, because ag is useful, but you're going to do sum, min, max, and many functions. But when you do sum, it's just easier to do dot sum. So we're basically doing the same thing to generate a table like this, but a much simpler table with just the sum column and another min, max columns. And then we just plot the simple table we generate of sums of the data grouped by shipment types into bar charts. Now we want to find the top 10 LTL carriers with the highest expenditure. So who are the carriers we're spending the most money with? So again, we're going to do group by. Okay, and now it's going to be carrier name, right? So let's insert a code block and tell it, okay, give me Python code that uses the shipments data frame, okay, to find the top 10 LTL carriers that had the highest sum of freight paid amount. So it's doing shipments type equals LTL, so it's filtering by LTL. Then it's doing group by on the carrier name to be able to sum all the rows for a given carrier, and it's summing that. Then it's sorting them in descending order, so the highest carriers come up, and it's picking the top 10. Here we go. Top 10 companies are from LTL, all LTL carriers who we have spent a lot of money with. We're spending a lot of expenses. Why is this important? Because then we can work with them to get better rates because our transportation costs are too high. Okay. So you can take a screenshot of this, put that in your Word document. Okay. Okay. Now you can do, we already did this. So we can copy this comment here. And delete this cell. Now you have to find the top 10 LTL carriers with the highest number of shipments. Okay, so again, we have to make a new coding block to generate with AI because it doesn't like editing your existing code blocks. It wants to generate this new code in a clean block. Okay, so we can get the same prompt, use the shipments data frame, find the top 10 LTL carriers with the highest number of records or rows in the data frame. So again, we filter by LTL, group by carrier name, and then do the size, and we get the top 10. Notice most of them are the same, but not all. So you have RC transport here, where there's no RC transport here, so we're giving it a lot of number of shipments, but it's not showing up in a lot of, in terms of dollars, we're giving it lots of small shipments to RC transport, for example. Okay. Then we do the same with TL. We did it for LTL. We're going to do the same with TL. So this should be TL and TL. Okay, so let's generate a new code block and say use the shipments data frame to find the top 10 LTL carriers with the highest sum of freight paid amount. Okay, very similar code. Oh no, it has to be TL, sorry, TL, not LTL. So it's the exact same code, just change LTL by TL, and you run the exact same logic, the exact same code, right? You can actually copy this code and just change this LTL to TL for this last bit. and I'll copy my prompt. With the highest number of shipments. Okay, so very similar code, just LTL change to TL. And these are TL carriers which we use a lot, so we need to negotiate better rates with them so that we can save money. Now you want to take a screenshot of this and a screenshot of this. And now we're almost done. Now we're gonna, the Pat suggested that we look into consolidating LTL shipments. Okay, come up with a strategy to consolidate LTL shipments. And this is where you really see the power of Python, because what we're going to do next is like really hard to do in Excel. Okay, so this is a criteria I am sharing with you to consolidate LTL shipments. You could have your own criteria. So United States is 3.62 million square miles with about 44,000 active zip codes. And so the average area covered by a 5-digit zip code is 82 square miles. So it's like, if it's approximately a square, it's going to be a square where each side is about 9 miles long. We can then have 3-digit zip codes. So if you have a 4-digit zip code, like, 48956, is 3-digit will just be 489, the leftmost 3 digits. That is a bigger region. And 3-digit zip codes are approximately 4,100 square miles. Right? And if the shape is relatively a square, each side is about 64 miles long. So within a 3-digit zip code, how long do you have to travel from one point to the other? Well, we know from mathematics that about half the side of a square is the average length between any 2 points in a square. That kind of makes sense too, right? It's actually about 0.52, but you guys take 0.5 is approximately be correct. So within a square, which has a size of 61 miles long, on average, you'll be traveling between any 2 addresses within that 32 miles. So traveling 32 miles to pick up different shipments or to drop different shipments, which were consolidated onto one truck, doesn't seem too bad. So basically what we're going to say is, okay, if you are going to the same 3-digit zip code and you have 2 or 3 shipments going there, just put them on the same truck, consolidate them, and then this truck will go and drop off the shipments to each customer in that 3-digit zip code. And on average, the truck will only need to drive 32 miles between successive customers. So don't just send 3 shipments to 3 customers in a 3-digit zip code. Send 1 shipment where you have 1 truck loaded with material for all 3 customers, right? So to be able to do that sort of consolidation, we first need to have columns in our data with 3-digit zip codes, which we don't have right now, right? And so we need to generate those columns, which are, origin zip has 5-digit zip code. We're going to generate origin zip 3 and destination zip 3. So let's go to code block generate with AI. Create 2 new columns in the shipment data. One is called origin zip 3, and it has the 3-digit zip code from origin zip. The second one is called destination zip 3, and it has the 3-digit zip code from destination zip. By taking the leftmost 3 digits Okay, so very good. It's creating 2 new columns, and it's taking the original column, which is already a string, and then taking the leftmost 3 digits. So let's check. And if you look at the end, we got these 2 new columns. If you look at destination zip, it's 46628. So 466 would be the 3-digit zip code. And it is 466. Now we can use this criteria. We can say Combine shipments when the 3-digit zip code for origin and destination match. So you're basically, have the same route. You're starting in approximately the same location, ending in approximately the same location. So these shipments can be combined. They have to be LTL shipments because TL shipments presumably are using up most of the truck to begin with. However, if you analyze the data further, you'll notice that we do have some small truckload shipments as well, which need to be consolidated. But for this lab, we're just doing the LTL work. So if you're going from the same 3-digit zip code to the same 3-digit zip code, and you're going in the same week, so it's not that the next shipment is after a month and you just send customer product a month early. No, that's not on. And you can't have a combined weight more than 40,000 pounds because the truck weight limit that for the load that a truck carries in the US is approximately 40,000 to 50,000 pounds, depending on the regulations of the highways and the state and so forth. So 40,000 pounds is the safe limit. We should be able to go pretty much everywhere in the US with that limit. If you could go up to maybe 50,000 with some of the larger trucks, but I don't know if all states or all highways allow that limit. So we're going to try to use AI, and if AI doesn't work, we'll have to do this up a little bit manually. Okay, so we'll give it a nice prompt. So we can say, using for the data in the shipments data frame, combine LTL shipments when with the same value of origin, zip 3, and destination zip 3, and the same week of the shipment. Well, do we have a column for the week? Well, we don't, but you can easily get the week from the ship date. So week of ship date. Include a new column that has the count of the number of shipments combined. Ensure that the total weight of the combined shipments is not more than 40,000. Yeah, let's see if AI can. So let's see. Oh, it's doing something. Let's see. So doing shipments week is creating a new column called week, which is extracting the week out of ship date. That's great work. Then it's doing LTL shipments grouped by origin zip, destination zip, and week, which is again great. Okay, but then it's doing this weird for loop and kind of going in the for loop. This is too complicated. We don't need to do all of that. We can just, for this group by, we can just sum up, sum up the shipments, because all observations within the group are going to have the same origin, same destination, and same time of travel, like same week of travel, so we can group them up. We don't need this if sort of thing, but let's run the code, see if it works. Okay, so we have origin zip, destination zip, week, combined shipment. Oh, that's no good. We don't want a combined shipment with just one shipment being combined. We want to combine more than one shipment. So let's update our prompt. Okay, let's rewrite it a little bit to make it easy. This is first of all, the code is too complicated. Secondly, we want to filter out when the combined ship count is 1. So combine shipments in the shipments data frame when origin zip 3, dest zip 3, and week of the ship date are the same. Include a new column that has the count of the number of shipments combined. only keep rows where 2 or more shipments have been combined. Also check for and exclude and filter out rows where the combined shipment weight is more than 40,000. Okay, so this is much nicer, see, because we can do everything with group by. Okay, so first we filter LTL shipments and we group by what we want to do. Okay, and then we aggregate weight, we take the sum. Okay, we don't need any of that actually, but anyway. Then it renamed the columns. Then it combined, then it filtered, then it only kept rows with more than 2 shipments. So I think that was the key. In the prompt, you need to specify keep these rows, delete these rows. It can apply these filters. Otherwise, it goes into this crazy for loop, so which we don't need. We can just filter out the rows to get to the result. And then we also want to filter out rows where only keep rows where the weight is less than 40,000 pounds. So let's look at these results, and this is much nicer. So here, for origin zip 102, destination zip 017, we've combined 3 shipments, and the combined weight is 37,962 pounds. Total freight amount we don't need here, because that's gonna, when we combine the 3 shipments together, we're gonna get hopefully cheaper amount of money spent. But it's good to know how much money we spent originally on those 3 shipments. Okay, but now we hope to spend less. Okay. So there were 4850 rows. So there were out of data set of with 50,000 rows, because it's a large data set. We had about 10% of instances where multiple shipments could be combined. And if you look at this, you see 50,436 rows. So this is a big data set. Working this in Excel can get messy really fast. Then we'll take a screenshot of this table with the combined shipment. And imagine doing this in Excel where you have to, even if you sort by origin zip 3, destination zip 3, and week, you still have to manually combine shipments and check that you're not exceeding the 40,000 weight, and then do the manual next week. It'll be like you'll spend hours doing it in Excel. But this was like 2 minutes in Python, right? So this is the strength of Python, where you've not only done some basic analysis on the shipment data, shown them their expenditure by shipment type, but you've also figured out how many of these shipments over these 4 months could have been consolidated into larger shipments, and you would have saved money on that, right? So you've done that as well, all in a short amount of time, using Python and using AI prompts. Now, you would have noticed that sometimes I don't like the code AI generates, and I kind of change the prompt. That just comes with experience. So I know that this combination for LTL shipments, I'm gonna have to do a filter on LTL, so only look at LTL shipments. I'm gonna have to do a group by to gather the rows together, which have the same origin and destination and the same time of shipment, the same week of the shipment. And then I'm gonna have to do some filtering on these rows where I can on the group by I can aggregate them, right? Or I can combine them, use it, and then I can filter out the ones which are too heavy, or the ones where there was no other shipment that week, so you could only combine one shipment, like with itself, like there's no other shipment to combine. Okay. So once you get a hang of, okay, what are the types of operations you need to do, you can tell if the AI did like a decent job or not, and you can then update your prompt to get the new code. Okay. Now, I do recommend that you hit this button and you look at the explanation of the code, so you understand, okay, what is this thing doing? Okay, it's filtering. What is group by doing? What does the aggregate function do? Okay. Aggregating data the ag function. Okay, so anyway, this will be the final screenshot. So then you can take a screenshot of this, put into Word, and then you'll submit your Word file as proof that you've done your lab. So, we were able to go through these 50,400 rows of data very quickly with Python, calculate all sorts of summary statistics, identify carriers where we're dealing with them a lot in LTL shipments and TL shipments, and then also look at opportunities to consolidate LTL shipments to save money. Okay, so that's it for this lab. If you're into problems or have any questions, you can reach out to me.